Suppose a plus b plus c equals to pi radians. We need to prove the following. Okay, let us begin. So here what we'll do, we're going to start from the given condition. That means here we have a plus b plus c that's equals to pi radians. Let's do one thing. Let's transpose c to the right hand side, and that's going to give us a plus b equals to pi minus c. Now clearly we have half angles here, so what we'll do, we're going to divide both sides with 2 such that we get a plus b over 2 equals to pi minus c over 2. Next, what we'll do, we're going to take the cotangent function on both sides. Now we know that cotangent of a over 2 plus b over 2, that's going to be equals to cotangent of pi over 2 minus c. Fine. Now we're going to expand the cotangent of the compound angle a over 2 plus b over 2 by taking the help of the formula. So that means if we have cotangent of a added to b, so that can be also expressed as cotangent of a multiplied to cotangent of b minus 1 whole divided by cotangent of a added to cotangent of b. Okay, so let's use this formula. So in the numerator, we're going to get cotangent of a over 2 multiplied to cotangent of b over 2 minus 1 whole divided by cotangent of a over 2 added to cotangent of b over 2. Now coming to the right hand side, what we have here is cotangent of pi over 2 minus some angle c. We know that whenever we have cotangent of pi over 2 minus theta, that is simply equals to tangent of theta. And since we are in the first quadrant, pi over 2 minus theta indicates we are in the first quadrant, so we are going to get a positive value. However, we know that the tangent of theta, it's simply the reciprocal of the cotangent function. So here in place of tangent of theta, we can also rewrite it as 1 over cotangent of theta. In other words, cotangent of pi over 2 minus theta, this is the same as 1 over cotangent of theta. Now for our case, what is theta here? So theta here is simply the angle, actually this is c over 2, not c. So theta is c over 2. So that means our formula should be 1 over cotangent of c over 2. Now what we do, we are going to cross multiply. So in the numerator, cotangent of a over 2 times cotangent of b over 2 minus 1, that gets multiplied with the denominator on the right hand side, that is cotangent of c over 2. So we will be getting cotangent of a over 2 times cotangent of b over 2 multiplied to cotangent of c over 2 minus cotangent of c over 2. That's going to be equals to, now this denominator gets multiplied to this numerator 1, giving us cotangent of a over 2 plus cotangent of b over 2. In the next step, what we'll do, we transpose cotangent of c over 2 to the right hand side, and that gives us cotangent of a over 2 times cotangent of b over 2 times cotangent of c over 2. This is going to be equals to the sum of cotangent of a over 2 plus cotangent of b over 2 plus cotangent of c over 2. And let's say this is exactly what we were needed to show. So we have successfully proved our problem. Hence, proved.